Hi, good morning everyone. I am KAMLEsh Kumar. I have just completed deep learning application project, and for that I have used FER 2013 to 2013 dataset learn facial expression from an images, and the dataset consists of 48 by 48 pixel grayscale images of the faces. The faces have been automatically registered so that the faces is more or less centered and occupied about the same amount of spaces in each image. The task is to categorize each face based on the emotion shown in the facial expression into 1 to 7 categories like angry, disgust, happy, sad, surprise, or natural. The training sets consists in 28,000 of images, and testing sets consist 3500 images approximately. So you can download this data from G file also, but I just downloaded dataset by using Kaggle Hub and this code. So for completed this project, I downloaded dataset from here, and then finally import the or all necessary libraries for the practical work, and then set the CUDA if GPU is available, else it will run on CPU only, and then setting up the ensure the consistency result by the fixing the random seeds devices, and then print the emotions of the classes. So preparing first the path for the training and testing datasets are defined. The dataset consists of facial emotions images categorized into different classes. To process the images, transformation are applied. The images are converted to grayscale with a single channel and resized to 48 by 48 pixels. For data augmentation, the training images used random or horizontal flip and random rotation 50 degree to improve the model generalization. All images are then converted into tensors and normalized with the mean and standard deviation of 0.5, and then get class label and their counts for training and test sets. This section calculates the number of images available for each emotions class in both the training and testing datasets. This helps to understand the class distribution of the dataset. This function is to plot the class distribution to understand how the class in dataset are distributed. So this is the training sets class distribution, and this is the test set class distribution. The bar plot displays the distribution of the images per class in both training and testing datasets. Each bar represents an emotion class with the count of the images shown above it, and these are the number of rows and number of columns. So basically, I plotting the sample data set from the training data sets. So these are the sample data set that our data set contains. So this section randomly select 25 images from the training dataset and displays them using matplotlib, and then finally select the dataset is imbalanced, so we compute the class weights to help the model treat under represented class more fairly. So for that I used compute class weightage from the sklearn compute weights using the balance strategy, ensuring that minority class get higher importance during the training. So, and then finally I initialize the model, the base model that I use to train in the future. So defining the model, this section defines the CNN for facial emotion recognition. The model consists of 4 CNN layer by fully connected layers to classify the emotions. These are the connected layers, batch normalization, max pooling, activation, reload, dropout, then flattened layer, then finally fully connected layers. And then model initialization. So initially I was using learning rate of 0.001. So define the model optimizer and loss function for the training of the model. I am using epoch size of 13, and then it will run and train the model. So after training the model for 30 epochs, I got training accuracy of 62%. Train for 30 epochs, track the loss and accuracy, forward pass, compute the prediction, and then final accuracy is approximately 62%. And then plot the prediction to analyze the how our model is performing. So visualize the model prediction, displays the 25 test images with their actual versus predicted labels. Model make predictions and result are plotted in 5 into 5 grids. Helps to analyze the classification, misclassification or classification and model performance, and then evaluate the models. So finally, after evaluating the model, we got test accuracy of 60% and test loss of 1.06, and then print the classification report, and these are the classification report of the model. And then finally plot the confusion matrix of that model, and here is the confusion matrix. We can clearly see that the happy is well classified, but fear fear and sad fear and sad and natural have some misclassification over here. Fear is oftenly confused with sad and natural. So this happen because of data set limitation. We have limited data sets. So, and then finally plot the performance of the training losses or training. So these are the plot the training performance of the model, and then finally save the model as base model.pth. And then after training the base model, I fine tune the model and use the defined parameters such space learning rate of 0.0012 to 0.001, batch size of 64 and 128, dropout is 0.3 and 0.5, and then train the model on these hyperparameter tuning parameters, combination of the eight test. So optimize model for best accuracy and generalization. More parameters can be taken, but it is taking too much time, so that's why only few parameters was taken. And then finally after taking these parameters, started the define the models, and then started the training with the same epoch 30. And then after training the all models, generally initially it trains on learning rate of 0.001, batch size of 64, dropout at 0.3, got accuracy score of 61% train accuracy. And then finally after training all the combination, I got 0.001 learning rate based model. For based model I got learning rate of 0.001, batch size of 128, dropout is 0.3. And then after training the fine tune model, I predict same as base model. So after this visualization, some emotions are misclassified in this prediction, also helps in identifying the pattern or biasness. And then plot the confusion matrix to see the how our model is performing. And then in this confusion matrix also we can see the model performs well on happy and surprise emotions. Fear and sad are oftenly confused with natural emotions, and some angry images are also misclassified as sad and natural. and these are the performance of the model along with losses and training accuracies. And finally print the confusion classification report, and these are the classification reports. And then finally test accuracy is 60% and test loss is 0.07 or 1.07. And after saving, and then save the fine tune model as best face emotion cnn.pts for the future use. And then finally train the pre-trained model as RESTnet model to the find the best model to predict the emotions. So this training is happen on 0.001 learning rate with Adam optimizer. And these are the this training is also done with the 30 epochs, and after running on 30 epochs I got training accuracy of 82%. And then then do evaluation of the model, and then got 62% of the accuracy on testing result. And then predict, and then plot the prediction versus actual, and then got the display the 25 sample images from the test set with the prediction and actual labels. And then also plot the confusion matrix for this model also. And then save the ResNet 18 models as the future use. And after doing this all training, I just built a Streamlit application to predict to predict the emotion on the live with opening with the webcam on any system. So when I run the application, this will open in browser, and when I do the start, it will predict the emotion of face on live.